All right, so we're back with the second part of this lesson. We have another example here where the principal angle is in quadrant 2, so it tells us that it's in quadrant 2, and sometimes it may not. So we're going to sketch the angle. We're going to determine x, y, and r, and then find out what the angle is. So if sine is 2 over 5, remember that this means the opposite side over the hypotenuse. Or you can think of it as y over r. So if it's in the second quadrant, whatever that point is, I know the opposite side, or y, is 2, and I know the hypotenuse is 5, but I don't know x. So we're going to figure that out. We're going to use the equation of the circle, or Pythagorean theorem, to figure that out. Okay, so if we solve for x, we get root 21, and I'm going to leave it as root 21. So now we know x, y, and r. So you could be asked to find sine, cosine, tan, but we're not. We're just asked to find the principal angle and the related acute angle. So the principal angle is from 0. The related acute angle is inside. So I have all the values, but since I was given sine is 2 over 5, I'll use that to find theta. So if I type that into my calculator, I'm going to get 26 degrees, but that isn't the right answer. That's not theta, because that's in the second, the theta is in the second quadrant, and 26 is in the first quadrant. So this is actually the related acute angle. So if I want to find theta, because it's in quadrant 2, I'm going to do 180 minus 26 to get 154. Okay, and the related acute angle is 26 degrees. How far is it away from the x-axis? So if tan is negative 3 over 4, again, it tells me it's in the second quadrant. So I know it'll look like this. So tan is opposite over adjacent, or y over x. So y is 3, x is 4, but it's negative. So this is not the negative value because I'm going up. So y is positive there, but we went negative on the x-axis. So the 4 is the negative thing. But I don't know r. So I got to find it. So again, we use Pythagorean theorem, or the equation of the circle. So we get r is 5. Again, I can use sine, cos, or tan to find the angle because I've been given, sorry about that. I've been given tan is negative 3 over 4. But I figured out what r is, so I can use sine, cos, or tan. But since I was given tan, I'll use tan. So theta is negative 3 over 4. And if you type that in, you get negative 37. But again, negative 37 is actually in the fourth quadrant because it's 360 minus 37. But what that's really telling us is the related acute, if I can spell acute angle. So beta is 37. So that means theta would be 180 minus 37, or 143. All right, so now that we have secant, remember that secant theta is the reciprocal of cos. So this would be hypotenuse over adjacent, right? So katoa, cos is adjacent over hypotenuse, so the reciprocal is hypotenuse over adjacent. Again, we know it's in the second quadrant, but I'm going to show you something later if it's not in the second quadrant. So if the hypotenuse is 3 and the adjacent side is 2, the hypotenuse can't be negative, right? So the radius can't be negative, only x can be. We don't know why. No, we don't know the letter y. So we're going to solve for y. So y is root 5, and I'm leaving it as an exact value. And since secant is negative 3 over 2, I don't have that on my calculator. I'm going to change it to cos. 2 over 3. And if I type that in my calculator, I get 132, which makes sense because that's in quadrant 2. So that's my answer. That's theta anyway. I just didn't show what the related acute angle is. So the related acute angle would be the difference between 132 and 180. So what, 48? Now, if it didn't tell me that it was in quadrant 2, and it just said between 0 and 360, then I need to think about what other quadrant is possible. So let's say this one here. Basically, cos is negative 2 over 3. So that makes sense in the second quadrant because according to the cast rule, cos is negative in quadrant 3 and 4. So that means I could have, if it didn't tell me it was in quadrant 2 and it just said it's between 0 and 360, I could have another angle down here that has the same ratio of -2/3. So if that was the case, once I figured out that and I figured out that, I'd also have to say that my answer could be 180 plus 48. So 228. So the cos of 228 and the cos of 132 would be the same. Okay, so if it doesn't say quadrant 1 or quadrant 2 or 3 or 4, whatever, it doesn't specify a quadrant, you have two answers. You have to show both. Okay, so we did this in a previous lesson, so I'll go over it quickly again. It's just saying that use 0.01 to show what sine, cos, and tan of 90 are. So this is, if this is the initial arm, which you never show, and this is the terminal arm, we've created 90 degrees. So the 0.01 is just an easy way to show. And because it's at 0, 1, the radius would be 1. X and y are there. X is 0, y is 1. So sine of theta was y over r. Right? We did that in the first lesson, or the first part of the lesson. So if sine is y over r, that means 1 over 1, which is 1. So the sine of, I should write 90 in there somewhere. Sine of 90 is 1 over 1, which is 1. So the sine of 90 is 1. Cos of theta in general is x over r. So the cos of 90 would be 0 over 1 or 0. And tan theta is y over x. So the tan of 90 would be 1 over 0, which is undefined. So the tan of 90 is undefined. And again, you can do this for any of the cardinal directions. So 0 degrees, 0 degrees, like we just did for 90, you can do it for 180, 270, or 0 and 360 are the same, right? So it would be easy for that. Now, use each trig ratio to determine all the values of theta from 0 to 360. So it starts out fairly simple. You just put it in your calculator. So theta is arc sine of 0.5299. And if you type that into your calculator, you get something. 32. But I know that there are two angles. So I have to consider what the other angle might be. Because we're talking about a ratio that's positive, and it's sine, that means it would be quadrant 1, quadrant 2. Because that is where sine is positive. So we have one angle at 32 degrees, and we're going to have another one in quadrant 2 that is 32 degrees away from the x-axis. So its related acute angle is 32. So this answer that we got to begin with was quadrant 1. What about quadrant 2? 180 minus 32 or 148? So the sine of 32 degrees is 0.5299. And the sine of 148 degrees is also 0.5299. So cos of negative 0.5. So before I type this into my calculator, I'm going to think about what this means. So a negative ratio means quadrant 2 and quadrant 3, because that's where cos is negative. It's positive in 1 and 4, but negative in 2 and 3. So let's think about quadrant 2 here. So if we type that in the calculator, you get 120 degrees. So now I got to figure out what the angle in quadrant 3 is that has that same ratio. Use a different color here. So I think about what the related acute angle is. What is beta? Well, that has to be 180 minus 120, which is 60. So that means since it's 60 degrees away from the x-axis in quadrant 2, it would also be 60 degrees away from the x-axis in quadrant 3. So I'm going to take 180, which is here. This is 180 degrees. And add 60 to it. And then finally, we have cotangent, but I don't have that on my calculator, so tan of theta is 1 over that. Or if I divide it, I get 3.7327. Again, I want to think about what quadrant we're talking about. So since tan is positive, in quadrant 1 and quadrant 3, I'm going to look for that. So if I type this into my calculator, I get 75 degrees. But again, I know that's not the only answer. That's quadrant 1, but in quadrant 3, I'm going to have another answer. So in quadrant 1, it was 75 degrees away from the x-axis. So that is my related acute angle as well. So even though it's the primary angle, because it's the angle I'm looking for, it's 75 degrees away from the x-axis. So this would also be 75 degrees away from the x-axis in quadrant 3. So in quadrant 3, it'd be 180 plus 75, or 255. Okay, so every ratio has two angles that belong to it. You just have to figure out what quadrant they're in and what angle it is. And that depends on the cast rule. So you're looking to see what the ratio is and if it's positive or negative. And then you think about the cast rule and think about where cos is positive, where is cos negative, sine, tan, where are they positive and negative. Okay, hope this helps. See ya.